Okay, once again, thank you for joining us. Students will be able to identify minerals based on their characteristics. Go to page 16 in your Earth Science reference table. That's the back page. Pick a mineral, tell us about it, add multimedia, make it fun. Okay, so Josiah said Galena, gray with black streaks in it. It's definitely metallic looking. Abdullah said graphite. Yep, found in the middle of pencils. We're going to be talking about that today. Again, garnet from Thomas. Dolomite. All right. Due to lack of time, I do want to move forward. So let's go. So today's instructional objective, we're going to be able to identify minerals by their characteristics. We're going to do some mineral ID review, and then we're going to practice taking a look at some. Welcome, Kira. I think some other people joined us. Link is in the chat. Okay, number one, why are minerals with identical composition different? You would think if they're made of the same stuff, they should be the same. It all comes down to the internal arrangement of the atoms. So if you take a look at these three images here, you can see that diamond's on the left, graphite is in the middle, and then we have a surface view of graphite. So they're both made out of carbon. Diamonds, because of the pressure that the carbon originally went under, it caused the carbon atoms to bond in four different directions, like in a 3D plane. Whereas with graphite, they all created these rings that you can see here in the third image, and they all are connected through weak bonds. This makes diamond really strong. This makes graphite really weak. Yet, they're both made of carbon. So, minerals are crystalline, which means their atoms are together, bonded together in a particular structure. You have strong bonds and you have weak bonds based on how they're put together. Diamond and graphite are both composed of carbon. Due to the different arrangement of atoms, graphite is soft, diamond is hard. And here's just another way to take a look at it. You can see how the diamonds are bonded in this three-dimensional network, whereas for graphite, it's more of a two-dimensional network. So some groups of minerals, we have carbonates. Carbonates are made of metal that are combined with carbon and oxygen. So you can see here we have hydrogen, calcium, carbon, and oxygen. They all react together to make this relatively weak mineral. We see this with limestone, we see this with calcite. CaCO3 is also the main ingredient in seashells. So sea creatures, and in fact the bones of organisms, contain calcium, and when those organisms die, their bones or shells are left behind, they create these minerals. So some of these are biological in origin. Next, we have silicates, which are made of silicon and oxygen. These are by far the most common, and SiO4 is probably the most common one that we're going to find on the surface of the Earth. We also see it in the form of SiO2. So SiO4 is silicon tetroxide, whereas silicon dioxide, also known as sand, is also super common. Now, the structure of this quartz crystal, it's relatively strong because it's in this pyramid shape. Remember from yesterday, we've got those four oxygens with the one silicon in the middle, and it is the most abundant mineral on Earth. So just a quick review of yesterday's techniques that we're going to be using to test hardness. I'm sorry, hardness is our first test of many. Now, hardness is nothing more than the resistance to being scratched. Now, glass is a great indicator of hardness, but we have some other things too. Like your fingernail has a hardness of 2.5. Copper penny has a hardness of 3.5. An iron nail has a hardness of 4.5. Glass is 5.5. Steel file, or any piece of steel, is around 6.5. And your streak plate is 7. These you all want to memorize. So I'm going to be providing this image along with some other materials on the Google Classroom. You can please take a look at that later. Streak, when we rub it on a streak plate, we get a powdered form of that mineral, and we could use that with our reference table, page 16, to identify it. Again, you want to have out page 16 today. Luster, we really have two types, metallic and non-metallic. Metallic is shiny like metal. Non-metallic is either shiny like glass or not shiny at all. Cleavage shows that it breaks naturally on flat planes, whereas fracture is jagged. Calcite, halite, magnetite, and sulfur all have special properties that help us identify them. We'll take a look at those later. And lastly, color. Color, no good for identifying minerals, but we do use it at the end if we're a little bit lost. Okay. Now, if you feel like I went over this stuff really fast, it's because I did. This is just a review of yesterday's material. Go back and watch yesterday's video if you are lost. Take a moment and answer the poll. Does this image exhibit cleavage or fracture? Okay, not bad. Pretty much everyone got that one right. And let's take a look at a typical Regents question. Which statement is best supported by the scale? A fingernail will scratch calcite, but will not scratch quartz. So calcite has a hardness of 3. Your fingernail has a hardness of 2.5. So no, a fingernail cannot scratch calcite because 2.5 is lower than 3. 2, a fingernail will scratch quartz, but not calcite. False. Fingernails cannot scratch quartz because quartz has a hardness of 7. 3, a piece of glass can be scratched by quartz, but not by calcite. Let's take a look. Glass has a hardness of 5.5. Quartz has a hardness of 7. Can 7 scratch 5.5? Absolutely. Now, can calcite, which has a hardness of 3, scratch the glass that has a hardness of 5.5? No. So our answer will be 3. Okay, we're going to shut down the Nearpod for now. So at this point, everyone should have out their Earth Science reference table. Sorry, I had this old beat up copy. I wrote on it a bit, but it will do. So we're going to be taking a look at some random minerals here, and we're going to be doing some mineral testing. What do I want to start with first? So I've got here this specimen. Okay, so this is sample number 32. Now, would you call this guy metallic in color or non-metallic? Yeah, I'd agree with you on that. So if you take a look here, I have a metal screwdriver. So this definitely appears to be metallic in some way. Whereas, let's take a look at another one. This guy does not, right? This guy just looks more dirty in color, for lack of a better word. Okay, so I know I can now instantly eliminate everything in this category because these are all non-metallic. So I know I'm either in metallic luster or the either section. Okay, next up is hardness. How hard is this? Well, here we have, I'm going to tear this off. Here we have our scale. I just pulled this down from that diagram that I gave you before. It says a fingernail has a hardness of 2.5. So let's see if I could scratch this with my fingernail. Absolutely not. This is harder than my fingernail. So I know this is harder than a 2.5. Next up, penny. If I can find my penny. Let's see if I could scratch this with a penny. Okay, I'm pushing pretty hard here, and I am not getting a scratch on there. In fact, if anything, I think I'm scratching the penny. So I know this is harder than my penny. Next is a nail. I don't have a nail available, so I'm going to skip that one. Next, we have a glass plate. So I'm going to take my glass plate, I'm going to put it down flat on the paper, and I'm going to take this and I'm going to slide my mineral across. Was I able to scratch the glass plate? Well, I'm going to go with barely. It seems like I can just put a line if I really hold down on it. I don't know if you could hear the scratching. Yeah, and if I run my thumbnail across it, I could feel the scratch. And in fact, you could probably see the scratch there. Yeah, there you go. If I just get it just right in the light. So I'm going to say that this is pretty close to what glass is. Glass is 5.5. So I guess the range for this guy, if I were to write down some facts about it, is, well, number one, for its luster, we're going to call it metallic. For its hardness, I'm going to say it's somewhere between a 5 and a 6, maybe? Hardness is sometimes a bit of a guess. Because I know my glass plate, again, has a hardness of 5.5. Now, in fact, we could narrow that down a little bit. So this is steel right here. This should be able to scratch this if this is softer than 6.5. So let's see if I can put a scratch in it. Yeah, I don't know how good that's coming up on the camera, but I am definitely able to leave quite a scratch in there. So, in fact, I'm breaking pieces of it off. So I know that this specimen right here, number 32, is definitely softer than steel. So steel is 6.5. So it's definitely somewhere between 5 and a 6. So let's take another look. Does this specimen have cleavage or fracture? Cleavage means that it broke onto flat sides. Fracture means kind of random shapes. I gotta say, this to me, I would say this is not cleavage. So cleavage might, you see flat sides on this guy? So this is more along the lines of flat sides. So you can see how very flat. This one almost looks like it was cut up. Okay, yeah, so this would be fracture. So that being said, let me do my pencil. I don't want to write on this with pen, but if you can see here, we've got metallic, good. For the hardness, we said between 5 and 6. So that narrowed us down to, actually, that only narrowed us down to this one right here, 5.5, right? So black to silver, fracture, yes, yes. Does it leave a black streak? Let's take our streak plate. Let me grab a clean one. Grab our streak plate and let's try and run it across. I would definitely say that's a black streak. Is it magnetic? Well, I feel it pulling just a little bit. So it's very ever so slightly magnetic. Ore of iron, steel. So we use this to make steel. Composition is Fe3O4. This is magnetite. So we've just figured out our first specimen. Okay, we're going to do one more. Here we go. We have this specimen right here. So specimen number 36. Definitely yellow in color. That's one thing we could say about it. Would you say it's metallic or non-metallic? Call it very good, non-metallic. So we know we're in this section. What about the hardness? So let's do that. We're again going to start off with our fingernail. Fingernail has a hardness of 2.5. Am I able to scratch this with my fingernail? Oh yeah, I can definitely scratch that. Again, I don't know how good that's coming up on the camera, but I can definitely scratch a line into it. So this is softer than 2.5. So for sample 36, hardness is less than 2.5. Okay, next step.